Happy day, students. We are starting a topic called waves. It's having all the details, basics, definitions, all I am starting so that you can refer it on. Okay, so let's start. What waves is basically? Okay, topic name waves. Now, if you talk about in real life, what are the phenomena in which waves are involved? So first of all, the things that we include is light. Okay, the other thing is sound. These are the basic phenomena that we involve with waves. Now, what is light? Light basically means energy which is coming to us from the sun. Okay, same way sound. Sound is also a form of energy which is produced by a source and it travels to some other people. Both are in wave form. So what we can say about wave? Wave is definitely a carrier which carries energy. Okay, the simple way definition that we are trying to bring is wave is the medium or wave is a phenomena which carry energy. Okay, now what are the other examples of wave? Like if you talk about waves in water, water is stationary, stands still. If you want to produce a wave, what we have to do? We have to drop a stone in it. When you drop a stone in it, waves are formed. Okay, so that is also a wave. So what we did, we created a disturbance in the medium so that the waves are created. So hence forms the definition. The definition of waves is a disturbance that carry energy and momentum is called wave. Okay, now what are the examples? Examples I already told you. Light is one example, sound is another example, and third example I told you, waves in water. Other than this, we have some more type of waves which are actually we are in daily life we are seeing. And what those are? Let's see. Waves in string and waves in spring. Also, you can take an example. Okay, so these are the types that normally we encounter or see in our daily life. Okay, this is the definition of wave. Now, what are the types of wave we have? That also we should see. Let's see what are the types of waves. Two types of waves normally are there. One is mechanical wave and other one is non-mechanical wave. Okay, there are two types of waves. Two types of waves. One mechanical and other one non-mechanical. Now what is mechanical wave? Mechanical wave is the wave which require medium for propagation. Mechanical wave means the wave which require medium for propagation. Okay, examples I will tell you later. Second, non-mechanical, a wave which do not require medium for propagation. The wave which do not require medium for propagation. Medium for propagation. Okay, so these are the classification of a wave, mechanical and non-mechanical. Mechanical means the wave which require medium for propagation. Non-mechanical means the wave which do not require medium for propagation. Let's take an example of light. Light is coming from the sun to the earth. Does it mean that everywhere medium is present? No. There are certain places in which we can say there is a vacuum. So what we can say about light wave? The light wave do not require medium for propagation. Okay, without medium also it can propagate. That's why it's so called electromagnetic wave. Okay, for its propagation electric and magnetic field is required, not any medium, any physical medium. Okay, but let's talk about sound. Does it require a medium? Yes. Sound requires a medium for propagation. So we can say sound is a mechanical wave and light is non-mechanical wave. The other examples that we took, waves in water. So obviously water is required for that. It's also mechanical. Waves in string required. That is also mechanical. Waves in spring, again spring is required. That's also mechanical. So only non-mechanical wave that we know is electromagnetic wave. That's light. All other waves are mechanical waves. Okay. There is one more classification that we have as far as wave is concerned. What is that classification? That classification is transverse wave and longitudinal waves. Transverse and longitudinal. Transverse waves and longitudinal waves. Okay, so let's talk about transverse wave first. Now, what is transverse wave? So we will try to define it in terms of mechanical wave only. We are defining this transverse wave in the form of mechanical wave. Now what it is? Now suppose that here is a source. Source is producing the energy and that energy is actually going to this point X. But if the energy is going in such a way that the particle of the medium are vibrating to transfer that energy from this point to this point. How those particles of the medium are oscillating? If they oscillate perpendicularly like this, if the source goes like this, the nearby particle also vibrate like this, all like this. Okay, so when the particles are vibrating perpendicular to the motion of propagation of energy, then it's called transverse wave. Okay, when the medium particles are oscillating perpendicular to the propagation of energy, then the wave is called transverse wave. Normally we make it like this, in this way. Okay, its example is waves in string. When you have a string in one hand and at one hand you are going to make oscillation like this. So what happens? This oscillation goes to the other end also in the same way, like this. Okay. So if this hand is doing like this, then at this end also it will be going in the same way. So it goes in this form. Okay. So what I am trying to tell you is, if my hand is oscillating in this way, every particle next to it also oscillates like this. This one also like this. Next one also like this. You can imagine it. Or you can take a string in your hand, tie its one end with the nail on the wall, and this end you make it like this. You see that here only you are creating the energy, but that energy goes to the other end also. In which form? In the same form in which you are creating the energy. Okay. So where energy is going? Energy is going along x-axis, whereas you are producing the energy along y-axis. Your motion is along y-axis. So when you produce this kind of wave, it is called transverse. You can do it in another way also. You can oscillate in this way. Okay. So here also, if the energy is going along x-axis, you are making your hand to vibrate along z-axis. So in this way, the energy also will go. So which wave we are calling as transverse wave? When the particle or the source, you say, is vibrating perpendicular to the propagation of wave, this is called transverse wave. Okay, particle is vibrating like this and energy is going like this. This is transverse. Its examples are what? We talk about examples of transverse waves. Then example of transverse waves are electromagnetic wave, that means light, EMW, or light, or waves in string, as I took the example right now. Waves in string. This is an example. Alright. This is transverse wave. If you talk about longitudinal wave, in longitudinal wave what happens? In longitudinal wave, if you are talking, In longitudinal wave, and basically longitudinal wave is an example of mechanical wave only. Okay, so in longitudinal wave what happens? In longitudinal wave the particle vibrates in the same direction as that of the wave propagation. Its example is sound. Now let's assume that I am talking. So when I am talking, I am a source. I am giving energy to air particle. Which air particle? Which are near to my mouth. So when I am giving them energy, in fact, when you put your hand over here, you will realize that from my mouth there is an energy is coming which is pushing the hand. So what it does basically? It does basically is all the air particles which are near the mouth, they are getting pushed. Okay, all the air particle near my mouth, all are getting pushed. Okay, upwards, this way, downwards, sideways. So what happens? This air particles move ahead. They are going to collide with the next layer of particle. They are getting the energy because of the collision. Okay, when the collision happens, something like this, the collision is happening. So this particle goes back and this particle goes ahead. Okay, then this particle is going to collide with the next layer like this. So this particle will come back and this particle will go ahead. Okay, so basically here energy is being transmitted through collisions of the particle. First particle gets the energy from the source, it moves, collides with the second particle, transfers energy. Second particle moves ahead and the first particle comes back to the mouth, comes towards the source, so that it keeps on taking energy again and again. So the particle which is near the mouth, it will always remain near the mouth and it keeps vibrating like this. That is longitudinal wave. So what is the definition of longitudinal wave? Longitudinal wave is, in this one, particles vibrate along the direction of propagation of wave. Its examples are what? Its example is sound and waves in spring. Waves in spring is also an example of this only. Okay. Now, one of the remaining part of the definition. Now we know that waves is energy, rather waves is a disturbance that carries energy and momentum from one point to the other point. That's absolutely fine. But does it carry mass also? Is the mass also moving from one point to the other point? Answer is no. As I explained you, when we are talking about the transverse wave, the source was making the disturbance at one end. That disturbance was reaching to the other end also. But does the mass which is in the hand of source also moving to the other hand? I am taking the string in my hand and I am oscillating it like this. Okay. Is this end of the string reaching this hand of mine? Answer is no. It remains in this hand only. Only the disturbance is moving like this, but the mass which I am giving energy is not moving. Exactly same way when we talk about longitudinal wave, is the air particle near my mouth are reaching to the other end? Answer is no. They are here only. So there is no mass movement happening in the wave. So what is the definition of wave now? It is a disturbance that carry energy and momentum without actual transfer of mass. That is the actual definition of the wave. I hope it's clear to you. Now let's discuss further about waves. So first thing that we are discussing here is we'll talk about transverse waves. Okay, the transverse waves are transverse waves, as I told you, you can say is waves in string. Okay, so waves in string, normally if you make it something like this. If this is a string, this is how the wave is transmitted from one point to the other point. Okay. Now these are called crest and this is called trough. There are certain basic terms that we need to know when we are talking about waves. Now what are those basic terms? basic terms is something is there called wavelength. Now what is wavelength? The general definition of wavelength is the distance or difference between two successive crusts or trough is called wavelength. So if I am calling this is a crust and this is another crust, so this is called wavelength. But this doesn't give us actual picture of the wavelength. What basically is a wavelength? Now wavelength basically is the distance traveled by the energy or wave. Distance traveled by wave in one oscillation of particles. Okay, all the particles here are oscillating. Now that also we need to remember when we talk about a wave. In that one, all the particles, right from the first particle to the last particle, all are vibrating. That vibration can be any motion, can be simple harmonic motion or can be any other motion. But if we talk about our syllabus, we have only simple harmonic motion into our syllabus because we are studying plain progressive harmonic waves. So we will talk about simple harmonic motion only. But it doesn't mean that the wave only carries simple harmonic motion. No, it carries all other motions also. But right now we are discussing about simple harmonic motion. So if the source is doing simple harmonic motion, all other particles which are carrying energy or which are involved in transfer of energy, all are doing simple harmonic motion only. If suppose I say longitudinal wave, if the source is doing like this, so next particle also like this, then the particle also like this, further particle also like this. All the particles throughout transfer of energy are doing same kind of motion, same kind of simple harmonic motion, same frequency, same time period, same wavelength. Okay, if we consider that the energy is not being lost, okay, there is no damping happening of the energy, then all the particles are doing same kind of a motion, okay, of same frequency, same wavelength and same amplitude. Okay, so let's talk about wavelength again. What is the wavelength? The distance traveled by the wave in one oscillation of the source or for that matter any other particle. Alright, so distance, it's a distance basically. So distance, how to write? Distance is written as velocity or speed into time. Okay, if it is a distance, then it has to be written as speed into time. So since we are calling wavelength as a distance and wavelength is normally denoted with lambda. So lambda is equal to speed. Speed is v and time is which time? They are saying in one oscillation. Okay, one oscillation is completed in one time period. Okay, the one time period is what? Time taken to complete one oscillation. So it is t. So lambda equal to velocity or speed into time. Further, we know that what is frequency? Frequency is number of cycles or number of oscillations in 1 second. Okay, number of oscillations in 1 second is called frequency and that is actually 1 by time period. The frequency is written as 1 by time period. Okay, what is frequency basically meaning? How many number of oscillations you are doing in 1 second. Alright, so frequency is equal to 1 by time period. So speed we can write as frequency into wavelength. Very important formula, very basic formula of wave and that is applicable for all type of waves irrespective of it is longitudinal wave or transverse wave. So, okay, so speed is equal to frequency into wavelength. Okay. Further, what the basics is in this one, then the next basic term is what is amplitude. Now amplitude means this is called amplitude. We represent this with A. Now what is this amplitude meaning? Amplitude is maximum displacement of the particle from its mean position as we studied already in simple harmonic motion. Okay, same thing applies in the waves also because all the particle for us are doing simple harmonic motion only in waves. Okay, so what is amplitude? maximum displacement of particle from mean position. Okay, this is amplitude. Now, we know if the particle is doing simple harmonic motion in that, then the maximum speed of the particle happens to be in mean position, and that velocity of particle maximum is at mean position, and its value is a omega. Now, this concept we have already studied in SHM. Same way, if suppose that we want to find velocity of the particle at some other position, let's say at y, this position is y, and we want to find the particle's velocity at this position, then we know that from same simple harmonic motion concept, it will be this, v equal to omega root over a square minus y square. Now, what is this omega here? Omega is angular frequency. Omega is angular frequency, which is written as 2 pi by t, that is 2 pi by time period, or written as 2 pi f. Okay, its units radian per second, like angular speed you can say. Okay, so this is angular speed or angular velocity or angular frequency. Its value is 2 pi by t or 2 pi f, and its unit is radian per second. Okay, so these are the basics what we have studied in basics: wavelength, frequency, time period, and amplitude. Okay, these are the basics of waves. Now, as we know that in wave, when the energy is propagating from one point to the other point, all the particles which are involved in propagation of energy are doing simple harmonic motion. So now what we have to do, we have to talk about equation of the wave. One equation which can show us, or which can say the relation between the position of the particle and the speed of the particle. Like if I make one transverse wave, something like this. In this transverse wave, we know that every particle is doing simple harmonic motion, and we have studied in simple harmonic motion that the equation of simple harmonic motion is written as something like this: y equal to a sine of omega t plus phi, where this is initial phase. Okay, same way all the particles in this one also are doing simple harmonic motion, but this is not a wave equation, it is simple harmonic motion. How to write wave equation? What is different in this? In this one, the difference is that there are many particles or infinite particles are doing SHM, whereas this is only the equation of single particle doing SHM. Then how to do it? Then in this one we have to introduce one more variable. What is that variable? That variable is this kind of simple harmonic motion is done by which particle. That means its position also. Suppose we want to know that this particle's simple harmonic motion. So this x also have to be defined, whether this x is 5 centimeter or 3 centimeter or 2 centimeter or 1 centimeter. So we need to be writing an equation which says that at this position, this particle is doing this simple harmonic motion. If an equation we can write which can relate all the particles doing SHM, that's called wave equation. So right now we have to write an equation which has two variables, x and t. That's a very simple thing. Now just concentrate on that one. Let's assume that here is the source and this is origin also. Okay, now first this starts oscillating. This is the source, it starts oscillating, let's say at some time, at time t. Is this particle also started doing oscillation at the same time? Answer is no. Answer is no. Why? Because it takes time. If suppose this is the source, it started moving in this way. So to reach to this point, the energy has to move from this point to this point, then only it will start moving. Okay, this is the source, it started early, but this point will start after some time. Though both are going to do the same kind of motion, but it takes certain time for energy to move from the source to other point. Okay, so time will not be same. So if I say my energy which is moving from the source with speed v. Okay, and this particle here at any time t, is doing an oscillation, like y equal to a sine omega t plus phi. This particle is doing simple harmonic motion at any time t, which is given like this. Then this particle must have started the motion at what time? If this is starting at t, obviously this started before. How much time before? Now we have to see how much distance is there between these two particles, x. What is the speed of the energy? V. It's constant speed? Yes. So how much time it takes to move from here to here? The time has to be x by v. Okay, so if this particle's equation is this, then what will be this particle's equation? We will say this particle's equation will be a sine omega t minus x by v plus phi. Okay, a sine omega t minus x by v plus phi. Now see this equation. Does it have x as well as t? Answer is yes. So this is the equation that we are searching. We call this equation as equation of the wave. We can simplify this equation. We can write this as a sine omega t minus omega x by v plus phi. Okay, so this is called equation of a wave. Okay.